Hello, everybody. Today we are going to go over Chapter 5, Introduction to Valuation and the Time Value of Money. This is probably, Chapter 5 and 6 are probably the two most important chapters, and it's very important to understand them very well if you want to do well and understand the other chapters well. So, time value of money, it forms the basis for all valuation. By the way, I'm going to shut my my video off so that we can focus more on the PowerPoint. So it forms the basis for all valuation in finance. In other words, anything that has to be valued, whether for purchase or for sale, will involve in some manner or form the time value of money. And it ranges from basic, simple running a factory to making small investments. It covers other areas such as estate planning, pension planning, how much insurance to pay out, oil drilling investments in Siberia, to big mergers and acquisitions. And it all boils down to the fact that when we invest in anything, the money is there for a number of years. So the premise, though, is as follows: money tomorrow is worth more than money today, right? That's understood. Whether it's just for tomorrow, a month, or a year later, doesn't matter. And the reason that happens is because we expect money to grow. And it grows because at the minimum, for example, you can earn interest rates. So let's just focus on interest rates for the moment. Money can also grow because, for example, if you buy a stock, the stock price can go up. There's no interest involved in there. But we'll see that ultimately it comes down to opportunity cost. So as long as you have the opportunity to invest money and it is a positive rate, then the values will differ between today and tomorrow. Okay? The only time that it never changes is there's no investment opportunities, or if you want to put it the other way, interest rates are zero. For example, in some countries or during the recessions, interest rates can be zero. For example, one country that has witnessed that a lot is Japan. But what we mean by that is, let's say you had $100 today. Okay, I'm sorry, this should be here. Zero today. Then let's say 2 years from today, what will be the $100 worth? Well, it won't be worth anything more because there is no interest rates if interest rates are zero, or if there's no opportunities to invest. The only time that the values change is if there is an opportunity cost to invest. I have to put it in interest rate terms if the interest rates are greater than zero at this point. I'll get to that in a second. So the question now comes is how much more is it worth, or how differently is it going to be valued tomorrow or the day after or the month thereafter? Okay. I'll always be using $100 as our as a example here. Let's say to start with a simple framework, we have $100 today, and we'll call it present value, and we'll put it in a bank that is paying a 10% deposit. What will its value be in 5 years? Now, first let me show it in the form of a diagram. So in other words, the question being asked is, I have $100 today, and I'm going to be investing it in a deposit, or I'm going to put it as a deposit in a bank, and the bank is going to pay me 10%. So how much will this money grow and accumulate at the end of 5 years? So that's the question. Let's see if we can answer. I'm going to go now back to the PowerPoint. I have to mention one thing. As we will be mentioning over and over, we can find the future value, as that's what we're trying to find out, using 3 different ways. We can use a formula, we can use a calculator, or we can use an Excel. So we're going to use most of the time the calculator method, but as you'll see, the calculator method is related to the formula, and the Excel sheet is also related to the formula. So for these 2 chapters, I will bring in the formulas, but thereafter, when we're going to be doing more advanced problems, I think the calculator will be sufficient. So to go with this, let's start here with the first slide here. What happens to your $100 at the end of 1 year? Now, you've learned in your other classes or in your math class, the value of 100 at 10% means you will earn $10 at the end of the year. So if this is the beginning of the year, this is the end of the year, you have 100. At the end of the year, you'll have 110 because you'll have 10% interest, right? The way to write that down is very simple. We say the future value is equal to the present value, and then we have the interest rates, and then we'll also take it to the power t, because it'll tell you how many years. But let's just focus on 1 year right now. So if you focus on 1 year, it says, let's say I have $100. I learned 1 plus 10. What does 1 mean? The 1 means the principal, and then 10% is the add-on interest, and it's for 1 year. So if I do that, then 100 times 1.10 makes it $110. So at the end of the first year, let me bring these two over to this side. At the end of the first year, I will have, I'm going to get this. All I know is that if I multiply this by 110, if I multiply this by 1.10, I'll have $110. What happens in the following year? Well, the same thing happens. Now, this 110 will also earn interest of 10%, and we'll see it becomes 121. If I go back here, what it means is in the second year, from period 1 to 2, I'll be having $110, right, at the beginning of the year. And if I earn 10%, how much will I get? I'll get $11. So the interest will equal to $11. And when I add it back to my principal, it'll equal to 121. Now, we can do the same thing here. In the formula, what will happen is we could have solved it directly by saying future value is equal to present value, which is 100, 1 plus the 10%, except I want to take it 2 years forward. So if I did that, it'll be $100. And then how do I take the 1.10 to the power 2? In my calculator, I'll say 1.10 yx2 equals to, and it gives me 1.21. So once again, in my calculator, if I wanted to take 1.10 to the power 2, I will just put in 110, and you'll see this button called y to the power x, which says take it to the power of what? I'll say take it to the power of 2 and equal to. So that will automatically give me $121. So the same thing continues. So as you go to year 3, it becomes, and let me highlight that, this one using this. So in year 3, it'll become 133. Multiply that by 110, it becomes 146. And then in year 5, it'll become 161.05. Okay, so to do the formula directly, now I'll increase this a little bit. This is exactly what we're going to do. We're going to say future value is equal to present value, 1 plus 10% to the power of 5. And if I did that, lo and presto, I get 161.05. So before we proceed ahead, what happened here? What happened here is we had said, let's try to find out what is the value at the end of 5 years if we put in $100 into an account today. And we've shown that this, at the time it earns interest and interest, it'll end up being 161.05. So why am I getting this color? Okay, so that's to use the formula. So let's recap. If you wanted to find the future value of a sum today, doesn't matter what, as long as you want to find out some value x going here, we call this value the present value, And whatever ends up here as the future value, we say, okay, future value is equal to present value, 1 plus R, the interest rate, and tell me for how many years. So that's using the formula. How about if we're using the calculator? Well, if you use the calculator, then the buttons are all given to you. So I'm going to use the BA2 plus buttons. So if you looked in the second row, the third row, you'll see these buttons: N, interest per year, present value, payment, and future value. And actually, all you need is these buttons to calculate the future value or the present value of any number. In this example, what did we have? Our present value was 100. Now, it's important that it's not necessary, but I'd recommend doing it, is to put your 100 as a negative sign, and I'll explain shortly. Future value, payment, there is no payments in between. That will come in chapter 6. So I would just for safety, always put in 0 as my payment. Then interest rate is 10. Now remember, in the formula we used a decimal, but here we'll use 10 in whole numbers. 5 is the N, so you always press the number first, then N, 10 higher. And then you press compute, which is on the top left of your calculator, and say future value, and out will pump 161.05. So that's doing the same work as your formula, but it's easy to do. All you do is to set the numbers. So you say 100 present value, 5 is your N, 10 is your interest rate, 0 is your payment, and compute future value. Now, if you're using Excel, then you just use the FV term, that is function. So you just say add function or equal to function, and automatically will say give me the interest rate, 5, 0, 5 is the N, 0 is the payment, 100 is the present value, and then this 0 by default says whether it's end of period payment or beginning of period payment, keep it always at 0, and then lo and presto, you get 165.01. Now, what happens if you don't put 100 as a negative? All that will happen is your positive 161 will show up as a positive. And we'll explain to that shortly as I make sure that I'm going through the notes carefully here. So, yeah, okay, so we are right there. So the important thing, therefore, to see is to understand why do we put in negative for present value or when we're using the Excel sheet. The reason is simple, and again, it need not bother you right now, but I might as well get it over it. The thing is that let's say you wanted to write something like A is equal to B. Let's say 10 plus 7 is equal to 17. In your calculator, the way the algorithms are written, they don't write it that way. They write it as A minus B is equal to 0. Or in other words, 10 plus 7, bring this over here, minus 17 is equal to 0. So the fact that the algorithms are written that way means that one of them has to be a negative term if you're going to say A is equal to B or X is equal to Y, because it's written the other way around. Hence, the reason for using the negative numbers. Now, as we go along and we do more of the problems, it'll become a habit and you won't even think about it twice. But it is important to remember to use it. So I finished the first part, which is just to get you an idea of the future value. But let's say we were going to ask a little bit more, try to understand the numbers a little bit more in detail. And you'll see that I'll be bringing my favorite person into class all the time, and that's grandmother. And grandmother asks all these interesting questions. And one of the things you have to remember, and let me make sure I'm still recording, and one of the things you have got to remember is that in order to reply to grandmother, you have to be very clear and make it as simple as possible. And secondly, of course, you have to, I joke in class that you have to speak loudly so she understands it clearly. So how would we explain this 161 to grandmother? Well, what we can tell grandmother is that, the extra amount that you're getting is made up of obviously interest rate, but there's two types of interest. One is a simple interest. Remember, we said 10% is the interest and our principal is 100, the present value. So that 10% is therefore here, right there. If it is broken up, let me get this correct. So it's the 10, 10, 10, 10, 10. So where did that would add up to $150. Obviously, the other part is the interest on interest. So if you recall, in the first year, we got 110. And then we had to earn interest on that because at the end of the 1 year, we had 110. Then by the time the end of second year comes, this is the beginning amount. This is the ending amount. So in the second year beginning, we got another $10. 10% of 10 is just $1. That how is what adds up to 11, and you end up in the end with 121. So we start year 3 with 121 now. On just the original principal, the 10% is this $10, but then we have 21 bucks more. 10% of that is $2.10. So that year we'll earn a total of $12.10. If we add it to the 121, that will make it 133.10. And so it continues. And then the beginning of the fourth year, we have 131, of which 10 is simple. The rest is the interest on interest. So that's 10% on $33.10. That's 331, adds up, etc. So the main point captured here is that, again, if there is, if we do mostly compounding interest in finance, and so when we find the future value of anything, it means that the money is reinvested, whatever interest you earn, and that's the number that the calculator, the Excel sheet, and the formula gives to you at the end of the day. Okay. So moving forward, simple interest can be thought of as earning interest in, if we want to define simple interest, it would mean just you invest $100, get the $10 simple interest, and you take it out so that you always leave $100 back. That's the equivalent of a simple interest, okay? But in finance, as I said, most instruments are valued on a compound interest basis. Now we're going to go a little bit more deeper, and the way to go in deeper is to say, what are some of the properties of future value? There are two things to remember. That is, one, that as interest rates increases, the future value of a sum, remember, there's just one number we're looking at as sum, increases. Also, we can also tell you that as interest rates increase, the future value increases at an increasing rate. So how do we show that example? Well, let's take a look at this diagram, which is also in your textbook. And so I'll try to magnify the glass. Let's take the first example here. So, oh, wait, let me show this. On the axis here is the amount, which is the future value. And on this axis is time. We're now going to find the future value of just $1 and tell you for different interest rates, what will be its value at the end of 5 years. So I'm going to go back first and start the case with 0 interest rate. So what did we say with 0 interest rate? With 0 interest rate, we said that the value always remained the same. So let me just go back to my chart here. So if I deposit into a bank $1, after 1 year, there's no interest rate, so stay at 1. No interest rate, stays at 1. No interest rate, stays at 1. No interest rate, and no interest rate. So it remained flat, okay? And therefore, The other way to view it from economic term is to say there is no opportunity cost, rather no opportunity to invest, hence the opportunity cost is zero. Okay. So because you have no opportunity, let's say that the economy is a full-blown recession. Nobody wants to have the money. And we had that recently in the financial crisis of 2008 when the Fed reduced the rates to barely zero. And this is and as we'll discuss later, that some countries are even gone into negative interest rates, which is also possible at this point. But sticking to R. So if you looked at this diagram here, I'm trying to reduce it enough so I can see it, yeah. So if there is no interest rate, then what we see is that the $1 remains the $1 all the way to 5 years. But what happens if interest rate is 5% over here? Then we'll see that the $1 will continue to grow and become $1.28. What about at 10%? And remember, we did that. The $100 became $161, but $1 therefore will become $161. Same thing is true if you give higher interest rate of 15 and a higher interest rate of 20. So the first rule is very simple to follow. As interest rates increases, the future value of a sum also increases. Makes sense? There's another thing you need to notice. Notice when we went from 0 to 5%, how much did we get more? We got 28 cents more. If I ever managed to put take my deposit of $1 with a 5% bank and put it at a 10% bank, how much more do I get up? So that's 38, 48, 58, so I'm getting 33 cents more. If I move from 10% to 15%, how much does it grow? Well, it turns out 51% more, right? Is that 51? No, sorry, 41% more. And then if I go from 2.01 to 249, I make 48% more. So we'll see that as you increase the interest rates, it goes exponentially higher and higher. So we say, which is the second derivative, the interest rates increase, the future value increases at an increasing rate. So as you go from 5 to 10, 10 to 15, 15 to 20, the increase gets higher and higher at that point. Okay, this is just to show you that example, that in other words, compounding can really make your investment grow. At high rates, the growth can be exponential, okay? And this is especially important these days when you're talking about retirement funds, etc. It makes a big difference if you're planning to invest for 30 years, and it'll be easy to show that even for small changes in interest rate, if you can earn 0.25% more, the amount that it will multiply into gets really high at that point. Okay, we're now going to use an example in your textbook, which is 5.2. And the question is very simple. It says, if you invested $400 at 12%, what is the accumulated value in 7 years? So we have three options. We can use the formula, we can use the calculator, we can use Excel. Let's do the formula first, and then we'll do the calculator later. So in this example, what you'll see is that the future value is equal to, remember, present value, 1 plus r to the power t. So the present value is 400. Again, the formula, we don't have to put the negative sign. 1 plus, what is the interest rate? It's 12%. Remember, we have to put decimals, 12. And how many years? 7. So if I took the calculator and did 400, 1.12, because 1 plus 0.12 is 1.12, the power 7, I'll do 1.12 yx7 equal to. So let me do that. So 1.12 yx7 equal to is 2.2107. 2.2107. So 400 times 2.2107, that's equal to, and I multiply that by 400, and I get 884.27. So in other words, my $400 will end up being $884.27. Grows, 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 grows. That was using the formula. How about if I use the calculator? Very simple. I put negative 400 for my present value, 7 for my N, 12 for my interest per year. There is no payments in between, so 0 for my payment, and compute future value, and lo and presto, I get the same number at that point. Okay. So moving forward, okay, so I wanted to see if I should do one more example, but we can wait. Let's just do the present value right now. So that covers the how to calculate the future value. Oh, I thought I'd done this. Nope. So that was to show you that, look, if you have some number today, we can predict some value into the future. The present value is the other way around. If I gave you some money in the future, can you tell me what it is worth today? So we're going to go the other way around. We have some value in the future, and we want to know what's its value in the past. Again, we said for that to happen, there has to be an opportunity to invest. So if you told me that you're going to get $10,000 in 5 years, can you give me an idea of what it is today? If there is no interest rate, obviously it's still worth 10,000. But what if there's a positive interest rate? Then if it's a positive interest rate, then the way we're calculating is saying, okay, I need to know what is this X, that if I were to then put it in a bank and earn that whatever interest rate, it amounts to $10,000. So once again, the opportunity cost principle, it assumes you have an opportunity to invest, and therefore you can say, I can give you a value for 10,000, understanding that the value I'm giving you is based on the opportunity cost, that if you had that value X today, you have the opportunity to invest it, and if we can know the interest rate or the growth rate, we'll tell you it'll should accumulate up to $10,000. So it's important that you understand that principle. The only reason we can give you a present value is we can say that if you had that money today, you could put it in a bank, and then it'll earn interest and interest and interest. And then if it accumulates to 10,000, we know it's the correct present value. So let's go and do another example on that. Let's say you're receiving $1,000, but it's 2 years from today. Grandmother says, you know, I'm getting to 1,000. Can you tell me what its value is today? And your answer will be the same. You'll say, okay, what's the interest rate? Let's say 7%. Discount rate, interest rate, will all be intermingling those terms. It's discounted because it's coming backwards. So the way we will tell her what it's worth today is to say, well, how much do I need today in order for me to, so that it grows to be 1,000 at 7%. So if I divide it by 1.07, I'll get 934 and then 873. So let me show you how that works. So you remembered that future value equals present value 1 plus r to the power t. This time I'm saying, give me the present value, I know the future value. So if I were to rewrite this formula, I'll take this over this side. So present value is equal to future value 1 plus r to the power t. I'm bringing this whole term to the bottom over there. So in other words, to find the present value, all I have to divide is 1 plus r to the power t. So in this example, if I divided 1,000, the interest rate is 7%. And let's just take it for 1 year. So use your calculator and see what you get. 1.7, 1,000 divided by 1.07 is 934.58. And then if I divide 934.58 by 1.07, remember, we're just taking 1 year at a time, so t is equal to 1. I divide it by 1.07, I will get 873.48. So if I had 873.44, sorry, today, I put it in a bank earning 7%, it'll become 934 next year, and then 1,000 at the end of 2 years. So again, lo and presto, the present value of 1,000 must be 873.44 given a 7% rate. Now that's using the formula. So the formula, of course, directly what I'll do is I'll do present value is equal to the 1,000, 1 plus 0.07, and I'm bringing it back 2 years. So if I did this in the calculator, which is 1.07yx2, I will get that as 1.1449, and then it'll give me 873.44 because I'll be multiplying this term by the future value, which is 1,000 times 1,000 times 1,000. Okay, so it's the, oh, what am I talking about? Take it back. We already divided by 1,000, so I don't need to do that. 873. So you can see the formula is just, present value is just kind of the reciprocal of the future value. The future value is present value 1 plus r to the power t. Present value is nothing but future value over 1 plus r to the power t. Now again, this is if you use formulas, but you may not use formulas if you use calculator. Well, that makes it very simple. In this case, what you'll do is you'll say, I want to find the present value. So what is the future value? The future value is 100. 2 is the end. 7 is the interest per year. There's no payment in between. Compute present value. And boom, you get the same answer, which is 873.44. Again, if you put in 100, it will show up as a negative number. If you put negative 100 for your future value, your present value will show up as a positive number. Let's discuss the problem right now. Assume you need $1,000 in 3 years. How much should you put in your bank today that pays 15% interest? So this would be an example of when you need to know present value. So the problem states, listen. I need $1,000 at the end of 3 years. Can you tell me what I should put in the bank today to accumulate that much? So of course you'll ask a question and say, well, how much is the bank going to give it to you for? And you say the interest rate I think I can earn is 15%. So obviously you need to find the sum such that when it earns interest 15 and add on interest 15, it becomes 1,000. Well, we can do it 3 ways. Excel. Did I show the Excel formula? The Excel formula is similarly the same. It's to find present value, you put in 0.07, that's for the previous example. 2 is the number of periods, 0 is the payment, future value is 1,000. 0 by default, compute, you get 873.44 at that point. But now we're going to use the formula. If you're using the formula, present value is equal to 1,000. 1 plus 0.15 is interest rate and is for 3 years. So if I did that, and let me use my calculator to get the new denominator, 1.15 yx3 equal to tells me it's 1.5209. And if I divide that by 1,000, I get 657.52. Sorry, 657.52. So it grows, 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 and becomes $1,000. 657.52 right there. Or you can use the calculator. Turns out the calculator will be very convenient. In this case, 1,000 is your future value. 3 is the end. 15 is the interest per year. 0 is the payment. Compute present value. And lo and presto, you get the same rates. So now we're going to do a little bit more to go deeper into the present value, especially its relationship over the interest rates, and we'll see. Now here, we'll have to show you differently. Let's say we had $1, and you have to interpret this number differently because the book gives you this diagram. But basically the idea is, in time, if the dollar that I was getting is in 5 years, what is its value today? That's how you have to interpret this number. So ideally, it would have been better to draw it like that, saying the following thing. So if I got $1 today, what would it be worth today? Let's say at 5% interest rate. And it'll turn out that it's worth about 78 cents at this point. What if it's 0? Well, if it's 0, it's still just worth $1. What if the interest rate was 10%? If it was 10%, then the value of it would be 62 cents. What would it be valued if it's 15 cents? It would be 0.50 cents. So that's how you'd look at it. It's a better way to show the diagram in there. So what do you notice? You notice, of course, that as interest rate increases, the present value of a sum decreases. And that makes sense, correct? If it's a high interest rate, then you need a smaller amount today to grow to become that number. But here's the important thing to note. At what rate does it increase? So you look at 0 to 5%, it decreased by 22 cents. From 5%, if you go to 10%, it decreased by 16 cents. From 10 to 15, it decreased by 12 cents. And from 15 to 20, it increased by 0.10. So in other words, as the interest rate increases, the present value starts to decrease, but at a decreasing rate. So in the future value, it increases at an increasing rate, and present value decreases at a decreasing rate. Okay? And the premise is again based on it. The higher the interest rate, and you want to know the present value, which is saying how much would I have to have today in order for it to grow to that number. If the interest rate is high, then you need a smaller amount at this point. Okay. All right. Let's do an example from your textbook. An investment cost $335 will pay you $400. Or you could put the money bank at 10%. So I'm just going back, it's in 3 years, sorry. So if I had an investment today, let's say somebody comes and tells you, listen, give me $335. And in 4 years, I say no, in 3 years, I will give you $400 back. Let me make sure the numbers are correct. Yeah. Now, as I said, alternatively, you could put it in a bank. So the question comes in is, well, should you take this project investment or not? How could you solve it? Well, of course, one way to solve it is to say, look, if I put this money in the bank, how much will it grow up to be? So if I had 335, I put it in a bank, and the bank is giving me 10%, is it worth it? So you can easily calculate that. Future value is equal to present value 1 plus r to the power t. I'm going to do it both ways, but eventually you'll see I do less and less of the formula. 335, the interest rate is 10% and it's to 3 years. So it's 335 times, I do 1.10, yx3 equal to gives me 1.3310 times 335 is 445.89. Let me make sure the interest rate is 10%. Yeah, so here we go. It's 445.85 as we showed it over here. So is this a good investment or not a good investment? The answer is obviously not, because this guy who's giving you this deal is only giving you $400. Whereas if I put it in a bank, I get 445.85. All right. So let's change around and ask the question, well, what interest rate is he offering you that he says he'll give you $400 back? Again, there are two ways to do this. I'm going to use the formula way. Oh, wait, before I do that, how about the calculator? If it was the calculator, all that I do minus 335 is present value, 3 is the end, 0 is the payment, and 10 is the interest per year. Compute future value. And low, presto, you'll get 445.85. So you can use the formula or the calculator. My feeling is most of you are going to use the calculators. But I want to ask another question related to this. If this person is giving you 400, what interest is he paying? So in this case, the calculator is much easier to use, but let me just show you what happens if you're going to be using the formula to do it. Maybe some of you do like formulas. If you remember, future value is present value 1 plus r to the power t. In this case, our future value is 400. Our present value is 335. We know the interest rate, it's 10. The only thing we don't know is t. Well, to solve it algebraically, you'll bring this down here. So it'll be 1.10 to the power t is equal to 400 divided by 335. Now, how do we take the t off? Let me just go back to my notes and just show you how we'll do that. So we have, oh, sorry, what am I doing? I'm losing it. I'm not trying to find out the time, I'm trying to find out the interest rate. So 3 is already known. I'm just trying to find out what is R over here. So I apologize, here. Get my eraser going if I can. So one more time, I'm trying to find out what is the interest rate that he's offering for 335 to 400. So to solve this, what I'll do is bring this 335 here. So equal to 1 plus r to the power 3. Now, how do I remove this 3 out? If I can multiply this by 1/3, cancel, cancel becomes 1. Then I'll have to take this to the power of 1/3. multiply both sides by 1/3. That's how we take a power out. So 1 plus r is therefore equal to, I'm going to solve for this, 400 divided by 335 is 1.194 to the power 1/3. Now to get this number, I go 1.194 yx takes you to the power of, I put in 3, but I don't want it to the raised to the power of 3, I want it raised to the power 1/3, so I'll press the 1/x and equal to. So if I do that, yx3 invert equal to, it's 1.0609, or r is equal to, I'm just going to do it slowly, 1.0609 and bring the 1 that side. So it's equal to 0.0609 or 6.09%. Again, why am I doing all this formula? Just because I said in the first few chapters I'll do the formula and the calculator, but you can use the calculator, and the calculator would be very simple. How would the calculator work? The calculator would say 335 is my present value, 400 is my future value, 3 is my n, 0 is my payment, compute interest per year, and lo and presto, you have the answer right there. But let me do it. 335 is present value, 400 is future value, 0 is the payment, 3 is the n, I, and you get the exact number, which is 6.0893%. So in other words, this person was offering you 6.09%, and he was compounding it for 3 years, and that's why you got 400. So at the end of the day, you're still better off putting the money in the bank because that's giving you 10%. So hope this was not too complicated, but we'll be doing other problems at this point. Here's another problem, and this time we'll just use the calculator to make it easy. Assume you need $80,000 to send your child to college in 8 years. You have $35,000. If you can invest it at 20%, is it sufficient? There should be a period here. If you can invest it at 25. In fact, there should be no if. You can invest it at 20%. Is it sufficient? So let's see how that works out. I have $35,000 today. Remember, we always say today. You say today, that means it's period 0. This is something I'll do more in, as we go along. 6, 7, 8. We need $80,000 today in 8 years. Is that sufficient? You say, what's the interest rate? 20%. Of course, the first thing I'm going to tell you is that if anybody offers you 20%, you better just not believe it. It's very difficult to earn 20% over 8 years. Yeah, there's a few hedge funds that do it, but they also take a lot of risk. So I wouldn't do that. So how can we solve this and say, well, let's just use the calculator and say, if we could earn 20%, let's see how much it will grow to become. Then we can compare it to whether it's above or below the 80,000. So I put minus 35,000 as my present value, 8 as my n, 20 is my interest per year, 0 is the payment, compute future value. So let me do this as we're doing. So it's 35,000, change sign, present value, 20 is the I, 8 is the N, 0 is the payment, compute future value, and it turns out to be 150,493.59. Of course, you'll get way above the 80,000. So the answer is obviously yes. Now, let's change the problem. I kind of make this into a story for the grandmother as usual. Let's say, grandmother, this whole 20% investment was suggested to you by grandmother, who had told her that your uncle was able to give you 20%. But then last minute she changes and said, no, that was false. There's no way he could give 20%. So the next question being asked in the problem is as follows. What minimum rate should the parent receive to reach the objective of $80,000? So in other words, you say, all right, that was not a good outcome. Let me just change that. This one of the problems with these tablets are that they're very sensitive. I hope my voice is not fading out. So the question comes now is, what interest rate should I earn in order to get this 80,000? So again, if it's a form calculator, it's very simple. You say minus 35,000 is my present value. 80,000 is my future value. 8 is my N. 0 is my payment. Compute interest per year. So let me do that. 80,000 is my future value. Compute I, and it says you need 10.89%. Let me just double check. 10.89%. So if you had 10.89%, that money will continue to accumulate, so that by year 8, it's equal to $80,000. Okay. So moving along with the chapter, yeah, that's important to know that the most important thing to know is in your calculator, you need to know 3 of the 4 to determine the 4th. But I'd like to say you need to input all 4 to determine the 5th. I put 0 for payment every time you don't need just to play it safe. So let's do a final example here. The example says, one, and then we have to do the rule of 72. It's example 513. You have 2.3 million investing at 5%. How long before it accumulates to 10 million? So notice, out of the 5 buttons that I have, and let me just rewrite the buttons again. So 1 was N, 1 was interest per year, 1 is present value, 1 is payment, and 1 is future value. So for present value and future value, one number, one sum, all we have to make sure is to put in these 4 to get the 5th. So we've solved for present value, we solved for future value, and we solved for interest per year. The last one was saying 10.89. But now let's do a problem we have to solve for N. In other words, let's say we have 2.3 million and it's being invested at 5%. So today's 2.3 million. At some point, it will grow up and become 10 million. So the question being asked now is, can you figure out how long it will take me? Well, the calculator, it's very simple, right? I have to just solve for N. So I put minus 2.3 is equal to present value. 10 is equal to the future value. I'm just cutting out the zeros. Investment 5 is the interest rate. 0 is the payment. Compute N, and lo and presto, it says it will amount to 10 million in exactly 30.122 years. Okay. Now there's also a formula to use. It's a little trickier, but let me just show it to you at least once. And then I won't show it to you, but some of you who are like using formulas, then you can go ahead and use that. So remember, this is the formula, correct? So what we said is we're going to be putting 2.3 million, and it'll amount to 10 million at the end. It's being put in at 5%. So this is the time when I'm saying, how do you solve for t? How many years do you think it'll take for 2.3 million to become 10 million? So here again, we do the same thing. We bring this 2.3 here. So 10 divided by 2.3 is equal to 1.05 to the power t. So 10 divided by 2.3 is 4.3478. Let me just double check here. Yeah. 4.3478 is equal to 1.05 to the power t. Now to take away the t, we need to take the natural logs. So if I take the natural log of 4.3478, then I can bring this t down, if you remember your algebra days, times the log of 1.05. And to find the natural log is simple. On your calculator on the left hand side, you'll see the ln button, which is the natural log. So if I press 4.3478 and then press ln, I get 1.4697 is equal to t times log of 1.05. So 1.05 log is 0.0488. And then I just bring this down here. So t is equal to 1.4697 divided by 0.0488. Recall 7 divided by recall 8 is 30.122 years. So you can see I got the same number using my calculators much faster. I did it over here, 30.122 years. Okay. So the last thing in this chapter is the rule of 72. It's a simple rule, you don't have to really learn it, but it's called the rule of 72 because it's a very quick way of determining how quickly can you double your investment. And it turns out that I can tell you two things. I can tell you how quickly you can double it, or I can tell you what interest rate you need for a given number of years to double your investment. So let's say I have $100 and I wish to double it in, let's say I'd like to double it to 200, and the interest rate is 12%. So the rule of 72 says the interest rate times the years should always equal to 72. So if I knew 12 years, 12 is my interest rate, what will get me the number of years to get 72? So I divide 72 by 12 and I get 6 years. So 12 times 6 is equal to 72. So it'll take me 6 years. All I do is divide 72 by 6 years. Now let me check that. Let me go to my calculator. I put in 100 as my present value, 200 is my future value, 12 is my interest, 0 is the payment, compute, and it turns out to be close, 6.12 years. What if I had the other way around? I need to know how much to double my money, but I like it to do it in 9 years. So you say, okay, remember, interest rate times years should equal to 72. If I like to double it in 9 years here, well, what should be my interest rate? Well, then divided by 72. So if you divide it by 72, it's 8. So you say 8 is my interest rate, 9 is my years. That is equal to 72. So if I can earn 8%, then I think, if I can earn 8%, I'll double my interest, my investment in 9 years. Let's check. So I'm going to put this down. Negative 100 is present value. 200 is future value. 9, we said, is the end. So here's the payment, compute the interest rate, low interest, so it's 8.006%. So we are off by a very little amount at this point. Okay, this is sufficient for chapter 5. Next class, we're going to do chapter 6. And then if you can master 5 and 6, you are in good shape. Thank you all.